So in this video, we'll discuss about how the velocities play out when a river is flowing and a person is trying to cross the river. Let's take this case of you see these two parallel lines in blue represent the river, which is flowing in this direction. The water is flowing in that direction. There's a person here who's trying to cross the river and he wants to reach exactly the opposite point, this point P. But then if he starts swimming straight, let's say this is the river, and then he starts swimming straight, the water will keep pushing him the other way. So eventually he will end up going diagonally like that. So he needs to start swimming in this direction so that eventually when the river pushes him out, he ends up at some point like that. So this is like the vector triangle law of vector addition. The person's velocity vector is like that. The river is pushing him this way, and then the resultant is this way. So you see that the tail of the first vector and the head of the next vector give the resultant vector. So this is the man's velocity, velocity of man, velocity of river, and then the resultant vector happens this way. So still, though the river keeps pushing him in this direction, his velocity or his effort is in the direction shown by Vm here. So let's consider this case and see how it works out. This man starts from, let's say, point A and wants to reach point B. So he starts swimming at an angle theta, shown here, such that the angle theta is such that though he gets pushed by the velocity, the river flow of the river in the direction this way, eventually he ends up at point P, which is exactly opposite, the shortest distance between A and P. If you draw, he is traversed. That is the net result that happens. Now, so he has chosen the angle theta in such a way that he ends up here. Let's say if he starts swimming this way with an angle something else, let's say angle omega, then he may end up here, this point, which is not exactly opposite of point A. It is away from P. If he takes a narrower angle, he may end up here. But he has taken an angle theta in such a way that he ends up exactly reaching the bank at the opposite side at point P. Now, given this scenario, we know the velocity of the man is Vm in still water. That means if the water is not moving, he can swim at a velocity, or in still water, his velocity is Vm. So still he swims at a velocity Vm, but if he swims in a moving river, he'll get pushed away. He can't reach the exact opposite point. He may end up somewhere here. So to compensate for that, he swims the other way so that he ends up at P. Now he knows the angle theta, so that he starts swimming at that angle effectively, and then he ends up at P. Now if you know the velocity of the man is Vm and the angle theta is known, what is the velocity of the river is the first question. The next question is, what is the time he takes to cross the river? Now how do we find that out? We know theta and Vm. We have to find velocity of river Vr and time t to cross the river. So we need to find Vr and t. For that, let's look at the right angle triangle shown here. Let's say we know this angle theta and we know that this is, let's say, A, this vector. This velocity in this direction is A and the angle theta is known. Then we know that in a right angle triangle, this is adjacent side and this is the opposite side. If theta is the angle, this is adjacent and this is opposite. So the opposite side will be A sine theta and the adjacent side would be A cos theta. But if we consider phi as the angle, then this would become the opposite side and this would become the adjacent side. If phi is the angle, then this side would be hypotenuse times sine theta and this side would be hypotenuse times cos theta. So basically we need to know the hypotenuse vector, and whichever angle we take, the opposite side of the angle becomes hypotenuse times sine theta, the other angle becomes cos theta component. So the addition of these two gives the hypotenuse, the sine component and the cosine component. Now if we use that, then to find the velocity of the river, all we need to do is, we know Vm is this way, we know the theta is this way. If you form a right angle triangle, this is the right angle. So Vm is the hypotenuse, this is the theta. So the opposite side would be Vm sine theta. So this is the velocity of the river, Vm sine theta. And what is the time taken to cross the river? For time taken is nothing but the distance is given as d. The distance is d. And we know that the velocity has to come in the denominator. But if this is the distance d, then we need the component of velocity along this direction. So what is the component of velocity along this? This is the dotted line here. So we know theta, we know hypotenuse is Vm. So this is adjacent side. The dotted line shown here is the adjacent side for this right angle triangle. So it's Vm cos theta. So Vm cos theta. So this is the time taken to cross the river. So if given a question like this, and we know that angle theta is given and the velocity of the man in swimming, velocity of the person in still water is given. For the speed of river, we just do Vm sine theta. For time taken, we just divide the distance by Vm cos theta. So you can quickly solve this if you have this understanding of the right angle triangle and vector law of additions. Thank you.